We're going to determine the convergence of this series using the ratio test. Now, I believe we already determined the convergence of this series using the integral test, but I want to do it with the ratio test because I just want to emphasize that there isn't necessarily just one right answer to which test to use on a series. Bottom line, if you meet the conditions to use the test, you can use whichever one you want to if more than one apply. You could use the one that you think may be a little easier to do. Let's go ahead and do this with the ratio test. So we've got the limit as n goes to infinity of the n plus 1 term, that would be n plus 1 times e to the negative n plus 1 over the nth term, which is n e to the negative n. Let's go ahead and see what we can do to simplify that. So we have the limit as n goes to infinity of, we've got our n plus 1. We can just split this e up using rules of exponents and distributing the negative through. So this would be e to the negative n e to the negative 1 over n e to the negative n. So we can reduce our e to the negative n's, and then I'm going to multiply numerator and denominator by 1 over n. So we'd have the limit as n goes to infinity of 1 plus 1 over n multiplied by e to the negative 1 over 1. So as we look at that, as n goes to infinity, this goes to 0, and so our limit is e to the negative 1. Well, e to the negative 1, we could also think that that is 1 over e, and e is 2.718, and so 1 over 2 point something, this is less than 1. So by the ratio test, since our limit is less than 1, this series converges.